Hello, in this video I would like to explain how to build a machine learning model using naive Bayes theorem. Okay, so we're going to do a naive Bayes classification. And the data we're going to use for both Visual Studio and RStudio is a house vote 84. Okay, house votes 84. So this is the data they compiled for the legislation record in the U.S. Congress. So if you want to see the data, you can just type House votes 84, okay? And one of them is this UCI machine learning repository. So let me go there, and then you can find all the information about that. Okay, so class name, all the column names. So when we do RStudio, they don't have the column name, but you can actually find the column name over here. Okay, and you can also download it, but I'll show you the easier way. Alright, so once you download the data, we're gonna divide the data into two parts, and one part is for training. So when we have a machine learning algorithm, we need to train them. We need to train them so that they can build a model. And then the rest of the data we're going to use for testing. So what we're going to do is from the data we're going to do a random sampling. So we're going to have 80% randomly sample the data for training. Also we're going to use 20% of the data randomly sample the 20% of data for testing. Okay. So what you want to do is we're going to build a model using the data for training. And then once you build a model using those models, and we're going to test it, we're going to test the models using the data for reserved for testing, so that we know how good each model is. Okay, find the tutorial for naive Bayesian classification using R on Canvas. Okay, so let me make a copy, and then let's do it together. Okay, so I'll make a copy of this, and then go to RStudio, and then save. Paste it over there. Okay. All right. So let's go one by one. So the R is a very compact program without all those other special purpose packages. So first thing we have to do is we have to install a package containing those Bayesian classification algorithm. Okay, so syntax is install packages. The package name is E1071. Okay, so let me install it. Again, you have to use a Control Enter. Control Enter. Okay, so it may take some time. Okay, it looks okay. All right, and then we need to upload it to your memory. We need to load it to your memory. So library E1071. Control Enter. Okay, so now this package is available. If you want to know more about this naive Bayes functions, actually in R, if you want to know anything about almost anything, what you have to do is, can you see that question mark, and whatever. Okay, so let me do it. Okay, so you can find naive Bayes classifier. You can find lots of information over there. So you don't have to read it right now, but you may need it later. Alright, so let's get the data. Remember, we're going to use the house votes data. So we can actually download it from that website and use it, but that's an easier way. And how about this one? So this one, ML bench, that's a machine learning bench. Okay, let's get the package. This package already contains the data. So So we're gonna have this data, House votes 84. Okay, so we're gonna make this data available for us. Okay, can you see that now? House votes 84. So this one is now, computer memory, so we can actually use it. So let's take a look. Can you see a view? So a view actually shows the data in a different editor window, different window. Okay, can you see it? So here we have a class, whether it's a Republican, Democrat, or Independent. This data may be very familiar to some of you, because if you use the Visual Studio for the Bayesian classification, basically we use the same data. Okay, so basically what we are trying to do is using all those legislation records, we may want to predict whether certain congressman or woman is a Republican or Democrat or something else. Alright, so let's go back. Alright, so also you want to know the names of those columns. Okay, so this one has the first one, the party information is available on the class, but all the other columns have some generic name. Okay, V1 all the way to V6. Alright, so let's get some summary data. That's summary. Okay, so as you can see over here, they have some tables of data. So in this data, there are 267 Democrats, 168 Republicans, and for the first legislation, no is 236, yes is 187, and abstain or something else is 12. So as you can see over here, we can actually get all the data about whether it's a yes or a no, and so on for each legislation. Okay, now we need to count how many rows are there. Usually we want to have a lot of data points, but this one doesn't really have a whole lot of data, but it's okay. We are actually just trying to practice the Bayesian classification. So let me count. So 435 number of legislation record or rows. Can you see that? N row, so number of rows. So N row basically provides a number of rows. Okay, and remember in a previous page we talked about we're gonna divide the data for the training and testing. So we want to have some random sample of randomly sampled 80% of data for training, and then we're going to use the rest of the data for testing. By the way, it doesn't have to be 80%. It could be 90%. It could be 70%. It could be, this number can be totally different. All right. So, but anyhow, so for this example, we're going to use 80% of the data for training, and then a rest of them for testing. Okay, so let's take a look. So our N row for House votes. So this one gives a 435. Okay, so if you want to have 80% of it, then all you have to do is multiply that by 0.8. Okay, so instead of retype this one, we can just use upper arrow. So go to your keyboard and did you find the up arrow? Okay, so we have that, and then multiply that by 0.8. Okay, so that is 348. So what this one does is, out of 435, number 435, and get a sample, a random sample, 348 numbers. Okay, so what that does is basically sample, okay, 435, comma, 348. Okay, so this is basically this sample 435, and out of 435, and you have 348 randomly sampled data. Okay, so this one goes like this. So okay, that makes sense, right? So idea is idea is we want to actually save these numbers in our variable. Okay, so idea is, so we assign these numbers into a variable s. Okay, enter, and then if you look at s, and then we have the same thing. So this will be so what you want to do is we want to use this vector, okay, this vector to get that's data for testing, and then we're going to get a data for the testing and the training. Okay, remember this minus s, okay, and s. So what this does is, let me show you. So what it does is, so from using this vector s, we can take the particular the legislation. Okay, so you can see that, yeah, move so fast, but you can get a randomly sampled 80% of data. And if you did your homework about R, you probably remember this minus s. That means what? Give me all the data except whatever is in s, minus s. Okay, so if you do that, so now we have two sets of data. Votes for training has 80% of the data for training. The votes for testing has 20% of data for testing. Okay, now we need to build a model. Well, this is it. Pretty simple, huh? So what you want to do is we build a model. Okay, we build a model, and what we want to predict is a class. Okay, this class is about whether the person is a Democrat, Republican, Independent, or whatever. Okay, using all the other columns. Can you see that tilde and the dot? So what that means is we want to use every column except a class column, and then using all these all the columns except the class column, we're gonna build a Bayesian, naive Bayesian model. Okay, so we're gonna build a naive Bayesian model using votes training data. Can you see that? Votes training data. Okay, and then we're gonna get all the output from the Bayesian model into a variable NB1. Okay, so Control Enter. I don't think I did it, so let me go back and then execute this one. Okay, so now we have votes training and the votes testing. Okay, and then alright, so now NB1 has all the information created by this model. Okay, let's take a look. And NB1 basically shows you all the conditional probabilities. Okay, in the concept lecture, in the lecture for concepts, we talked about all those likelihood and in terms of conditional probabilities. Okay, so these are all those likelihood and those are conditional probabilities for likelihood. For more details, you need to review the lectures for conceptual part. Okay, so now we have all the the conditional probabilities available in NB1. Okay, also remember the Laplacian option, Laplacian correction. So if you want to, for example, sometimes a conditional probability can be 0, and then we're going to have some problem. Okay, so you can actually add you can actually use a Laplacian correction, and that is also explained in the lecture about concepts. Okay, and then you can actually add a value 1 or something else. Okay, everything is the same. So we're gonna build a Bayesian model using naive Bayes. Okay, and then we want to predict about the class using all the other columns. Okay, that's a tilde dot, so all the other data, all the other columns, the data is votes training, and that is 80% of the House votes data. Okay. All right. So we have two models. Okay, and NB2 is the result after you apply the Laplacian correction. Okay. So let's do some prediction. Okay. This time we need to do a prediction using the data reserved for testing. Okay. And also remember the votes testing also contains the class data, whether there is a Republican, Democrat, or whatever. So we need to get all the columns except the first column. So that is a -1. Okay. We do the same thing for the second model, NB2. Okay. And there's a vote testing using all the columns except the first one, because that's the one we actually want to predict. Okay. So let's do some prediction. Okay. All right. So once you have that, we can actually make evaluate the model. By the way, if you want to see what's in there, you can just go to Pred 1, and then they have all the data like this. Okay. And the same thing with the Pred 2. Okay. So if you want to evaluate the model, we're going to create tables like this. Okay. So what it means is this model predicted a 54 people, okay, as a Democrat, okay, and then 3 Republicans also as a Democrat. So obviously there are some errors. So this is actually correct one. So the model predicted a Democrat as a Democrat for 54 people, Republican as a Republican for 26 people. So these are two, the 4 and the 3, and these are the errors. Okay. So they predicted a Democrat as a Republican in case of 4 people. They predicted Republicans as a Democrat 3 times. So we will discuss how to evaluate the models using various ratios such as accuracy, precision, and others. Okay. Over here, when we made the predictions, they actually made a classification. So let me show you. So they already made the predictions about whether the person is a Democrat or Republican, and so on. This one is based on 50%. So any of those probabilities greater than 50%, they classify them as either Democrat or Republican or independent or something. So instead of those, we probably many times want to know the actual probabilities. Okay, and to do that, we do exactly the same thing. Okay, but this time we use we add this parameter raw. So if you add a parameter type raw, okay, and then they will actually give the probabilities. Okay, so let's do that. Let me run it. Okay, let's run this one as well. Okay, let's take a look. So using the first model. Okay, so now we see associated probabilities. The first one, the testing data set. So that was like 9.98 over 10, 10 to the minus first power. Okay, so basically 0.998. Okay, almost 1. And being a Republican is a 1.44 over 10 to the third power. So it's practically 0. Okay, same thing for the second one, and so on. So we can actually calculate these posterior probabilities. Okay, so all right, so this is how it works. Okay.